24th question. Yeah, very important. 23rd, also 23rd and 24th, very important. Yes. So, but anyway, you asked me 24th, so we'll go to 24th.
Sorry, even I didn't get 24th. I forgot about that. Yes.
Okay. All right. So 24th is this. So here, determine if f is defined by this is continuous function. So we have to discuss continuity of this function, right? So where we need to discuss here, at 0 we need to discuss. At 0 we need to discuss because now let's say we have taken a point which is not equal to 0. Let's say at x equal to a we need to check where a is not equal to 0. That means what? A equal to either 1 or 2 or 3 or 4 or whatever it is. Understand? But a is not equal to 0. If at all you check this now, we have to check this continuity of the function when x is not. So then x is not 0. A is not 0. That means what? X is not 0. So therefore we have to take this one only. Okay, f of x is always this. F of x then automatically becomes what? X square into sine 1 by x. That's it. So now what about the continuity of this function? Okay, continuity of this function. 8, 2, 3, 4, whatever you want to take. So x square is polynomial function continuous and sine 1 by x is trigonometric function continuous. Continuous function to continuous function is continuous.
Continuous. Yes.
If at all you take which is not x equal to a, which is not 0, any point it can be 0, it is not 0, it can be 0 0.1, 0 0.2, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, it can be any point which is not 0. Now, if at all we check at x equal to, let's say at x equal to 0, we need to check. X equal to 0, we need to check. Okay, so then what will do then? Limit x tends to 0. X is not 0, but x is tending to 0. So limit x tends to 0 f of x. So what you should take here f of x? You should take here limit x tends to, which is not 0. No? If x is not equal to 0, here x is not equal to 0, tending to 0. If x is not equal to 0, you have to take this. That is x square into sine 1 by x. Yes, sir, we have to take this. So you should understand here, when x is tending to 0, okay, here you need to understand this. As x is tending to 0, you understand this, right? Here sine 1 by x, x is not 0, understand properly. X is not 0, x is something, but it is tending to 0. Then what will happen here? This will be between minus 1 to 1. Yes or no? Yes or no?
Yes, so sine 1 by x domain is minus 1 to 1.
Yes, the range, sine 1 by x range. Yes, the sine 1 by x
Range.
lies between minus 1 to 1. So therefore, what we need to do is here, we need to first write here for this only. For this I am doing. See what I am doing. I am using sandwich theorem. I am using. Sandwich theorem, you remember last year. Sandwich theorem. Sandwich theorem last year. Sandwich theorem we used. What is that? Here, f is less than or equal to, f means f of x. F is less than or equal to g is less than or equal to h. Understand? F is less than or equal to g is less than or equal to. This is how the function. Now, limit x tends to a, f of x. Okay, limit extends to f of x is L, and limit extends to a, h of x is also L. Then automatically what happens, then automatically, limit extends to a, g of x is also automatically L. Understand? This is also tending to, as x is tending to a, this is tending to L, this is also tending to L, then between also tends to L. That's what you need to understand. That's what is sandwich theorem. Is that okay? Sandwich theorem. Sandwich means you understand sandwich between. Okay. upper one bread and down one bread, and in between some jam or water. G, jam. So whatever. So H, limit of F is L, limit of H is L, then limit of G also becomes L. So that's what is the sandwich theory. Okay, but in simply what you need to understand here, okay, this sandwich theory. Okay, and but simply what you need to understand, I told you here, as x tends to 0, sine 1 by x is belonging to -1 to 1, whatever it may be. X value, whatever it may be, 1 by x is some infinitely big number, whatever it may be, but its value is like value lies between -1 to 1. So x square 0 into, you can write like this. This you can write 0. This tends to 0 into this is some value between -1 to 1. This value is some value between -1 to 1. Some whatever it may be, but some value between -1 to 1. What you can do? This is 0. Yes or no? Okay.
Yes, sir.
This is one way you can understand. The other way is, see here, sine 1 by x lies between -1 to 1. Yes or no?
Yes, sir.
Actually, you have to do like this. Okay, that is one way, easy to remember. Another way is this. Sine 1 by x so I'll write sine 1 by x. Sine 1 by x is lies between -1 to 1. Yes or no?
Yes, sir.
So here
Yes,
now we'll multiply x square. So minus x square less than or equal to x square into sine 1 by x, which is less than or equal to x square. Yes or no? X square I multiplied, x square I multiplied. Yes.
Yes, sir.
Now what I'm saying is we can apply limit. Limit x tends to 0 minus x square, which is less than or equal to limit x tends to 0 x square into sine 1 by x, which is less than or equal to limit x tends to 0 x square. This is 0. Yes or no? This
Yes,
is,
sir.
this is 0. Now limit x tends to minus x square is 0. And this is also 0. This is also 0. Then whatever it may be, in between whatever it is, 0 less than or equal, something less than or equal to 0 means what? In between also?
It's
Then,
0.
Limit x tends to 0, x square into sine of 1 by x is 0. Okay?
Yes, sir.
Yeah, like that. So this is 0. So now next, this is equal to f of 0. What is f of 0? When x is 0, f of x is 0. That is f of 0 is 0 only. Na? When x is 0, f of x is 0. If you put
Yes,
x equal
sir.
to f of. So what did you understand? Limit value is 0 and f of 0 is 0. Therefore, it is continuous. Okay? So solution, you do like this. You do like this. So limit, how do you find limit? Limit you find out like this. Limit, this is the function. Limit x tends to 0, x square into sine 1 by x is 0, which is equal to sine f of 0. Therefore, f is continuous. Continuous. Otherwise, you can do like this also. There's nothing wrong. Here you should write this value 0 into some value here. Value between -1 and 1. So that you can write also, but if you write like this, then it is more clear.
Yes, sir.
So this is also find all points of discontinuity of f, where f of x is sine x by x. This is also same. Whether did you get it or not? I don't know.
So that was, I was going to ask that also. But this is 23rd is a little easier.
So should I erase this?
Yes, sir.
Other people. Ashita, able to follow? Ashita, are you able to follow? Yes, okay. Yeah, you just make it repair so that. Yeah, okay, anyway. So then let's go for Then 23rd. Okay, we'll have discussion. We'll have discussion. 23rd, we'll have discussion. So 23rd. So we can have discussion. So you find all points of discontinuity of f where it is like this. So where we have to check is we have to check at x equal to 0. At x equal to 0, we need to check because at x equal to 0 only function may have different values. Here you have different values. So at x equal to 0, because otherwise, if x is less than 0, only this is a function. Okay, this function is obviously continuous. Because your sin x is continuous, and x is continuous, f is continuous, g is continuous, f by g is also continuous. Here linear function is continuous always. Okay, so therefore it is continuous. Sin x. So simply how do you write? You see, okay, this you at x equal to, I am checking. So first step, I am checking at x equal to 0. Okay, at x equal to 0, how do I check? So limit x tends to, now here two ways defined. Therefore, we have to use left hand limit, right hand limit. Limit x tends to 0 minus f of x. I am writing directly sin x by x. Yes or no? As x is tending to 0 from left hand side, sin x by x. So this is what is LHL. Limit x tends to 0 minus f of x. Okay, equal to, what do I get? What is this? Can you tell me? Sin x by x, you know, as limit x tends to 0 minus or 0 plus also, sin x by x is, you know, no, limit x tends to 0, sin x by x.
1.
Yes, 1. That means what, you know, limit x tends to 0 minus sin x by x equal to, limit x tends to 0 plus sin x by x. Both are same only, no? Then only its value is 1. Yes or no?
Yes, sir.
Yeah, this is 1 only.
Yes, sir, got it.
LHL is 1. RHL, what is RHL? That's also limit x tends to 0 plus if it is more than 0, then is x plus 1. This is also 1. And this is equal to f of 0. When f is 0, f of 0 is 0 plus 1. Same thing. So LHL equal to RHL equal to function value. Therefore, what is the conclusion? Therefore, continuous at x equal to 0. Next, number 1. Number 2. Here at x equal to a, where a belongs to what, you know? A belongs to minus infinity to 0, up to 0. A belongs to minus infinity to 0. Any point it can be. Okay? Like this we have to check. You understood?
Yes, sir.
Yeah. Then what will happen here is, now limit x tends to a plus a minus I don't need to take. I need not take a plus a minus because for a plus or a minus, this is only sin x by x, f of x. So a is what? A is minus infinity to 0. Whether it is from positive side, negative side, whatever side it is, limit x tends to a. Here f of x is sin x by x because a is minus infinity to 0, less than 0. Minus a is less than 0. So this is what we discussed. So what is this? So here sin x is continuous, x is continuous. So sin x by x is also continuous. Or you can write sin a by a. Okay, which is sin a, f of a. Or you can say simply, okay, yeah, sin x by x. Sin x is continuous, x is continuous. Where? In minus infinity to 0. Therefore, sin x by x is also continuous. Like this also you can write. I think many problems we must have written like this. Okay, this is step 2.
Yes, sir.
Step 3 is what? F of x equal to x plus 1. Okay, where x belongs to 0
comma
to
infinity.
Open 0 to infinity, because at 0 it is something else. So that is continuous, of course. 0 to infinity. This also continuous. Why it is continuous? Because it is linear function.
Yes, sir.
So I think the sin x is continuous, cos x is continuous, sin x plus cos x, sin x minus cos x, sin x into cos x, all are continuous.
Yes, sir.
So this is also like that only.
Mm.
Okay, this 19th,
Yes.
19th, did you do? 19th question. Show that the function defined by g of x equal to x minus integral part of x is discontinuous at all integral points, where integral part denotes the greatest integer less than or equal to x. 19th, did you do?
Yes, sir.
What, Rishta, did you do 19th?
Yes, sir.
No doubt.
But it was mostly theory only, no, sir.
Yeah, yesterday we did the same thing, no?
Yes, sir. Same.
Yes,
Yesterday you
sir.
explained the same thing, no?
Yes.
Theory. Yes, sir.
Okay. For what value of lambda is the function defined by this is continuous at x equal to 0? What about continuity at x equal to 1? 18. 18 is to be discussed. We must have done, but I will discuss once. Yeah, you can
Yes.
tell your answer. 18. Can you tell your answer? 18. For what value of lambda the function is continuous at x equal to 0? First question here, at x equal to 0, what values of lambda it is continuous? Okay, at x equal to 0 now let at x equal to 0 f is continuous. That's what he gave, continuous, then lambda equal to what is the question? Yes or no?
Yes, sir.
For what value of lambda function is continuous at x equal to 0? So the question is, if at all f is continuous at x equal to 0, then what is the value of lambda? Okay, continuous means what? That means limit x tends to 0. Okay, limit x tends to 0 minus f of x equal to limit x tends to 0 plus
Plus
f of x equal to f of 0.
f of 0.
This is what we need to write because their left and right both are there. Therefore, we need to write left and right limit. So here 0 minus here lambda into here x square minus 2x. Okay, that's yes or no? This equal to
Yes,
0
sir.
plus is 4x.
4x plus 1.
Yeah, here limit I will need to also write limit because as long as we don't write we don't substitute 0, we should write limit. Otherwise, we should substitute 0. Here also limit x tends to 0 plus we need to write 4x plus 1. Here f of 0 is what? F of 0 is lambda into 0 square minus 2 into 0. Yes or no? F of 0.
Yes,
Yes,
sir.
sir.
So this is now lambda into 0 equal to this is 0 plus 1 equal to this is 0. What did you understand from this? 0 equal to 1 you got. What is the answer?
Sir, I think it is discontinuous at 0.
Good. So lambda into 0 equal to 1 you got. This is what you got. What is the value of lambda for which this is continuous? For discontinuous is correct. For no value of lambda, answer you should write like this. For no value of lambda, f is continuous at x equal to 0. That means what? For no value of lambda is continuous at x equal to 0. That means lambda value, whatever you put also, it's not continuous. You cannot make it continuous.
Yes, sir.
You can't make it continuous. Whatever value if you put also, you cannot make. Let's say you got lambda into, you got, let's say here, you got here 1 by 2 you got, equal to 1 you got. Then you can put lambda equal to 2. Yes or no? If
Yes, sir.
this is
Yes, sir.
if this is the case, but here you got this not the case, you got a lambda into 0 equal to 1. Whatever you put lambda also will not get 1.
Yes, sir.
Yeah, what about continuity at x equal to 1? At x equal to 1,
It is
whatever.
continuous because the only scenario over here is 4x plus 1. And because that's a
Exactly.
linear polynomial, it's
Yes,
continuous.
sir.
Yes, linear function. Polynomial, therefore. Yes, linear polynomial, therefore, continuous, right? Good. So here we should be able to present. So your presentation depends on your understanding. How clearly you are presenting, that clear you are in your understanding. Okay, your understanding is so clear and deep, then you can present it nicely. Okay, all right. So that's 18. And your A and B values, you have to make left hand limit equal right hand limit. Yes or no?
Yes, sir. Same thing.
Okay, right. So these all you got. Okay, 17, 18, 19. Just a minute. Just a minute. Just a minute. Yeah. Okay. Okay. Yeah, 25 is also very simple and easy. So then we can. So what about 20? Yeah. What about 26 to 29?
Sir, I didn't do those questions.
Okay, all right.
Sir, I looked it up and then I understood it, so I did it. I looked up one question and then I got how to do it, so I did all of them.
Good. Okay. So one question I'll discuss because here, okay, we'll discuss 26. Okay, this is 26 is important and like these questions, few questions I'll tell you from exemplar problems, I'll tell you. This is important one. So thing is that here, like previous lambda question we discussed, no? Here also same thing. Find value of k so that the function f is continuous at the indicated point. Okay, in each of the questions from 26 to 29. Now, indicated point, it is continuous. So what is the indicated point? At x equal to pi by 2. So what is given? Now like this, given f of x is continuous at x equal to pi by 2. That's what is given. So what does it mean? Here left hand limit, right hand limit is not there. When x is not equal to pi by 2, that means what? When x is less than pi by 2 or x is greater than pi by 2. X is not equal to pi by 2, meaning x is less than pi by 2 or x is greater than pi by 2. Okay, that's the meaning. Huh? X is not equal to pi by 2 means what? If it is not equal, then it must be either greater or lesser. So even if it is greater or lesser, this is f of x value. If this is f of x value. So therefore, now we need not take left hand limit, right hand limit because both left hand limit, right hand limit, this one. Therefore, we should take limit extends to pi by 2. Limit extends to pi by 2. Limit extends to pi by 2. F of x equal to f of pi by 2. That is the definition of continuity. So limit is equal to function value. So here limit extends to pi by 2 f of x. We'll write now. Limit extends to pi by 2 f of x. What is that? K into cos x by pi minus 2x. This equal to f of pi by 2. F of pi by 2 is what? When when x is pi by 2. When x is pi by 2, that is f of x is 3. So f of pi by 2 is 3. Yes or no? This.
Yes, sir.
Yes, sir.
Okay, all right. So here, now here what we can do is one trick we'll apply here. One trick we'll apply. This one trick we'll apply like last year we discussed actually. I taught this one. X is tending to pi by 2. As x is tending to pi by 2. Okay. So here yeah. x minus pi by 2 I'll write is x minus pi by 2 tends to 0. Yes or no?
Yes, sir.
X minus pi by 2 tends to 0. As x is tending to pi by 2, x minus pi by 2 tends to pi by 2 minus pi by 2. X minus pi by 2 just substitute, na? X value you have to
Yes, sir.
substitute in. X value is pi by 2, so tends to 0. This much is clear, right?
Yes, sir.
Now let y equal to x minus pi by 2. Is that okay?
Yes, sir.
Yes, sir.
Now let y equal, instead of writing x minus pi by 2, x minus pi by 2 all the time, we'll write y. So then x equal to what? Y plus pi by 2. Okay, this small arrangement we must make. Now here limit. As x is tending to pi by 2, y tends to 0. Hope you are clear.
Yes, sir.
As x is tending to pi by 2, y tends to 0. So here k into, here cos of x is what? Pi by 2 plus y. We are writing everything into y terms. So pi minus, here 2x, here 2x. Otherwise 2 into x is y plus pi by 2, whatever. Okay, is that clear? Everything is clear here. I am converting everything into y.
Yes, sir.
Yes, sir.
This is what is 3. This is what is 3. So now limit y tends to 0. Now little arrangement here. K into here cos of pi by 2 plus y. Cos of 90 plus theta. Second quadrant cos is minus. Second quadrant cos is minus sin y. Okay, this is minus 2y minus pi.
Pi.
This becomes what? Pi minus 2y minus pi. Because 2 gets cancelled. If you take it inside. Minus 2y. So minus you can cancel off. And then whatever is left is your answer. Minus cancel off k by 2. Because sin y by y as y tends to 0. Sin y by y as y tends to 0. Sin x by x is 1. Huh? Sin y by y is also 1 as y tends to 0. So continuity definition is this. Ashrita, you must have heard in a video. What is that? Limit extends to a, f of x equal to f of a. That is the definition. Limit extends to a, f of x equal to f of a. Now limit value should be equal to function value, then it becomes continuous. So that is the thing you need to apply here. But this is little or tricky question where you need to arrange something. Okay. Or directly you can take this also. Directly also you can take 5 minus 2x equal to y you can take. That's also okay. Then also okay, all right. Okay, then remaining all are easy. Continuous at here, continuous here, these all are easy actually. Very easy. 27, 28, 29, very easy. So direct those. Okay, 30th will go.
So I didn't do the 30th question.
Okay.
I did till 29.
Okay. So we'll have discussion. So 30th you can do, not a problem, but okay, we'll have discussion. Here find the values of a and b such that the function defined by whatever that is. Function defined by f of x equal to 5ax plus b and 21 is continuous function. So 30th, its continuous function means continuous at 2, continuous at 10 also. So therefore, what we can write is f is continuous at x equal to 2. That's one. So if f is continuous at x equal to 2, that means what? Limit extends to 2 minus f of x equal to limit. Here you need to understand, we need to find out the values of a and b. That's the main thing here. So therefore, now first thing we need to write is left hand limit equal to right hand limit, because first limit has to exist. 2 plus f of x equal to f of 2, but I need not write that one. This much is enough. So limit extends to 2 minus f of x. What is that? Limit extends 2 minus f of x is f of x when x is tending to 2 from left hand side. Then that means x is less than 2. That's 5.
Right.
Equal to limit extends to 2 plus f of x. Now
X
when
plus
x,
b.
yes, this is ax plus b. Now from here, this is 5 and this is 2a plus b equal to 5. This is one. And next one. Now f is also continuous function. So continuous means everywhere it is continuous. F is continuous. F is continuous at x equal to 10. No, limit extends to 10 minus f of x equal to limit extends to 10 plus f of x. Thank you. Thank you, Anjit. Thank you, Anjit. Ten minus f of x. So as x is tending to 10 from left hand side, that is here ax plus b, no? Yes or no?
Yes, sir. Yes,
So that
sir.
is 10a plus b equal to, this is how much?
21.
21. So what you should do now?
You have to solve the linear equations.
Yes. So now we have 2a plus b equal to 5. These two you need to solve to find out a and b. As simple as that. Only continuity definition you should know. These are all easy ones.
Yes, sir.
Ashita, you are able to understand? Ashita? Yes, okay. Okay, you're all very intelligent people. You can understand easily, not a problem. The only thing is that you need to listen, that's it. So you will understand everything. Okay, so next, only 2 minutes left, then you again log in. So meanwhile, we are going to go for, yeah. Okay, I did not send a video based on, yeah. So one thing is here, yeah, one thing is composite function. I thought to tell you about composite function. Okay, anyway, I'll tell you one point. I'll tell you composite function. What is that? That f is a function from a to b, and g is a function from b to c. Then there exists a function from a to c, okay, which is called G circle F, okay, G circle F. That is G circle F is a function from a to c, defined as G circle f of x equal to g of f of x. I'll tell you what is the meaning. Okay, so here let's say your a is here, b is here, and c is here. 1, 2, 3, a, b, p, Q, R. Function means, you know, every element in A should have one and only one image. For this, only one image. For this, one and only one image. For this, also one and only one image. So therefore, F is a function from A to B, and G is a function from. Now, if I keep one more A to R, if I keep, then it will not be function. So clearly, F and G are functions, yes or no? Now,
Yes,
G,
sir.
Yes, sir.
G circle F is a function from A to C. A to C. Why? Because here 1, 2, 3, here P, Q, R we write. Now 1 to A to P. So that is 1 to P. Next 2 to A to P. That is 2 to P. Like this. 3 to A, 3 to B, B to Q. So that is 3 to Q. Now this is a function. This function is called G circle F.